Air quality is monitored routinely over time from the ground for a small number of substances. But what KORUS-AQ does is it provides many perspectives from space, aircraft, and the ground to measure a wealth of things that will help us interpret air quality.
So these focused studies in air quality are part of this integrated observing system. So we have satellites giving us sort of the big picture. We have air quality monitors on the ground. But the nice thing about the airborne campaigns is they tie the two together, and you can see it in 3 dimensions.
Our instrument was on the smaller NASA aircraft, what we called the remote sensing platform. So our job was to give measurements that are very similar to what the future GEMS satellite is going to measure.
GEMS is the first one to monitor air quality in Asia region from geostationary platform. So far, all the air quality remote sensing from space has been low Earth orbit, and GEMS is going to be the first one to measure air quality on an hourly basis in high spatial resolution.
We ultimately want to be able to use these measurements to improve our knowledge of what the emissions rates are. So to do that, you take these measurements of concentrations and you use models to go backwards in time and say, well, how would you have to adjust what you think the emissions are to arrive at this end state that we measure?
KORUS-AQ successfully demonstrated the capability to provide integrated measurements from airborne, shipborne, and ground-based measurements. This will significantly improve the remote sensing capability and its accuracy.
In the future, we're going to hopefully have a constellation of geosynchronous satellites, and projects like KORUS-AQ can help us understand specific regions that will be covered by these satellites in the future, so that we can better understand the kind of data that we're going to get.
So that's our job now, is to use the airborne measurements that we were able to achieve during KORUS-AQ and all of these companion measurements to test those models and identify what aspects of them need to be improved so that we're ready when GEMS starts providing data.